For a seriously prolonged stretch of time, specialists have been enthusiastic about exploring space to uncover what lies past our nearby planet group. Yet the discovery of Oumuamua overwhelmed stargazers as they were puzzled about whether it was a pariah spaceship, a comet, a space rock, or a totally unclassified thing. In a surprising new development, Oumuamua has unexpectedly reappeared and is sending signals to Earth. What do these confounding signals mean? Are we facing a potential extraterrestrial encounter? Join us on this hypnotizing journey as we unravel the mystery behind Oumuamua's return and the strange new signals just a short time after its discovery. An Israeli-American speculative physicist caused a stir with the publication of his remarkable book, Extraterrestrial. He proposed a dazzling perspective, arguing that Oumuamua was, in fact, a probe sent from our planet, with the mysterious flying object being named a courier from a remote location. You would expect the scientific community to embrace its extraterrestrial origins, but it's more complicated than that. That is the reason, before diving into the causes of Oumuamua's startling return and the messages it's sending to Earth, we need to explore its identity further. Beginning in the autumn of 2017, Robert Warwick discovered Oumuamua using the Pan-STARRS telescope at Haleakala Observatory in Hawaii. The presence of the odd flying object Oumuamua set off a significant disturbance in how we could interpret space. What makes this thing truly sensational is that it's not Earth's most vital experience with an unidentified celestial object. In truth, Earth spectators witness numerous UFO, unidentified flying object, sightings every year. However, few of them are confirmed. Oumuamua, nonetheless, stands out as one of the most captivating and cryptic of all. When you hear the term UFO, you might imagine flying saucers piloted by extraterrestrial beings with enormous oval heads and thin bodies. However, the more nuanced term UAP, unidentified aerial phenomenon, serves as a broad term encompassing any odd flying object that hasn't been previously identified or categorized, possibly originating from beyond our planet. It could be a space rock, immense debris, or even an alien spacecraft. The discovery of Oumuamua represents a long-anticipated moment for scientists. For years, they had theorized and eagerly awaited such a groundbreaking event, hoping to solidify their belief in the existence of great spaces beyond our nearby planet group. Now they have undeniable evidence that the universe extends far beyond the boundaries of our sun-controlled system. All in all, Oumuamua astonished everybody. While scientists had anticipated a more conventional round or irregularly shaped celestial body, Oumuamua's fascinating properties indicated it was unlike anything seen before. Initial observations compared its shape to a stogie or perhaps a wiener, but upon closer inspection, it appeared to have the form of a pancake. Its size was relatively modest, measuring around 3,377 feet long, 364 feet in width, and 62 feet in thickness. While this may seem large for an interstellar object, it's still comparatively small. The story of Oumuamua's discovery is as captivating as the actual object. On October 19, 2017, astronomers identified this abnormal thing drifting through our nearby planet group. By then, Oumuamua had been moving for 40 days since its closest approach to the Sun and was a staggering 21 million miles from Earth, moving away from the Sun. To put this into perspective, that distance is roughly 20 times the range between the Moon and Earth. When Oumuamua was first found, the overall astronomical community quickly designated it as 1I/2017 U1, initially reasoning it was a comet. However, it was soon observed that the object had no comet's tail. As the extraterrestrial origin was firmly established, the name Oumuamua began to gain prominence. This name reflects the belief that it is a courier from space, which became even clearer with its return, as it started sending puzzling messages to Earth. These signals were captured by precisely calibrated telescopes on Earth after its initial visit. Data regarding Oumuamua's trajectory was collected by instruments like the Pan-STARRS 1 telescope, part of the Space Watch Network, the Canada-France-Hawaii telescope, CFHT, the Very Large Telescope, VLT, and the Gemini South Telescope in Chile, along with the Keck Telescope in Hawaii. Being both small and faint posed a significant challenge for observation, especially as it was already a couple of million miles away when we first observed it. In fact, it slipped past everyone's notice in early September 2017, considering that its brightness had dimmed to an apparent magnitude of around 13.5. As it continued to withdraw from Earth, it became increasingly difficult to see. By the end of October, its brightness had faded to an apparent magnitude of 23, rendering it virtually invisible to the naked eye. Oumuamua's unusual trajectory provides insight into its possible origin. According to astronomers, it appears to have come from the direction of Vega, a star in the Lyra constellation. Oumuamua's orbital eccentricity, measuring around 1.20, is the highest ever recorded. What does this scientific language mean? We should break it down. With such a high orbital eccentricity, Oumuamua can exceed the Sun's escape velocity, suggesting it could eventually leave our planetary system and journey to various corners of the universe. This discovery confirms that Oumuamua is indeed an interstellar object originating from a solar system thousands of miles from our own. Several hypotheses have been proposed by scientists to explain the origin of this puzzling object. We should examine these theories closely as we delve deeper into unraveling the mysteries surrounding Oumuamua's existence. Its presence in our solar system has enchanted researchers, uncovering new revelations and raising numerous questions from the outset. Experts acknowledged it might be a comet, yet the belief was quickly uncovered. Inquisitively, the speculation of it being a comet has actually reappeared. So, what unequivocally is a comet? Comets are stunning celestial components. They are fundamentally enormous interstellar objects made from dust and ice that pursue a circular orbit around the Sun. If you somehow manage to sum up their most distinctive part, it would without a doubt be their long, streaming tails. These massive transients are often considered relics from the beginning of our solar system, leftovers from the violent development of planets and stars billions of years ago. In a way, they are like time capsules of the universe, preserving a portrayal of a period when the Sun, stars, and planetary bodies were still in their immense infancy. But what do these comets look like? Imagine them as colossal lumps of dust and ice with a frozen center, appropriately known as the nucleus. Typically, a comet's nucleus measures around 10 miles in diameter, which is roughly the size of an average community. However, these nuclei remain frozen until they experience close proximity to the Sun. As they gravitate toward our star, the Sun's heat transforms the icy center into gas, and this outgassing produces brilliant streams of gas and dust that trail behind the comet. The interaction between this gas and the accompanying dust creates a voluminous, faint cloud around the nucleus, reasonably named the coma. You've probably seen artistic depictions of comets with their distinctive tails. In fact, comets often have two separate tails. The dust tail, which can extend for many miles, follows a wide, gently curving path behind the comet, while the ion tail consistently points directly away from the Sun. Throughout history, Earth has been visited by several comets. These magnificent visitors provide us with invaluable glimpses into their formation and evolution, offering snippets of data about the universe's capabilities. One such glorious pilgrim is Halley's Comet. This immense comet measures about 5 miles in diameter and 16 miles long. It follows a long elliptical orbit like many comets, circling the Sun approximately every 75 to 76 years. The last time we had the pleasure of seeing this celestial marvel was in February 1986. However, this wasn't the first time Halley's Comet graced us with its presence. After its appearance in 1682, English astronomer Edmund Halley, the comet's namesake, predicted its return in 1757, and he was remarkably accurate. There's even evidence that Halley's Comet appeared in the 1066 Bayeux Tapestry, highlighting its long-established relationship with our planet. While Halley's Comet takes the spotlight, it is by no means the only comet to pass through our solar system. One less well-known but equally fascinating comet is Shoemaker-Levy 9, which did not impact Earth but rather our neighboring planet, Jupiter. Scientists believe this comet split into 21 pieces under the influence of Jupiter's gravitational forces in 1992, eventually crashing into the gas giant in 1994. This galactic accident was observed from Earth and even from the Galileo space probe. The impact was estimated to be equivalent to the blast of 6 million megatons of explosives, a truly stunning event. Then there's Comet Hyakutake, known for its cold, blue streak and a faint tail. This comet is well known for putting on one of the most captivating comet shows in 20 years. In March 1996, it passed within 9.3 million miles of Earth, marking the closest it had come to the Sun in about 9,000 years. This experience was remarkable not only for its closeness but also for its ability to amaze scientists as it crossed interstellar space. Comet Hyakutake emitted X-rays at levels multiple times more than anticipated in 1996, and the Ulysses spacecraft inadvertently passed through the comet's coma. This unexpected encounter revealed that this brilliant wonder stretched over an astonishing 350 million miles, making it potentially one of the largest comets ever recorded, nearly 2 times the length of any other known comet. Comets, including their extraordinary size, are a couple of surprising models in the fabulous, gaudy motorcade of various comets. Comets like Hale-Bopp, Borley, and Anna have all similarly impacted our radiant record. The interest enveloping Oumuamua has incited a couple of specialists to re-examine their hidden choices. Jennifer Bergner and Darrell Seligman have recently referred to have gotten back to the plausibility that Oumuamua might be an interstellar comet. Their hypothesis suggests that, no matter its eccentric shape, small size, and specific flight plan, Oumuamua could indeed be a comet of interstellar origin. While most comets are rich in ice and release broad amounts of water vapor and gas when moving closer to the Sun, Oumuamua acted differently. Observations of Oumuamua didn't reveal the customary comet story, which raised questions about its characterization. Nevertheless, drawing from her wide expertise in cold space objects, Bergner proposed an extraordinary explanation. She hypothesized that Oumuamua could have emitted hydrogen gas into space, giving it a remarkable acceleration. This specific method of propulsion can be attributed to the radiation that permeates space. When this radiation interacts with the water ice on Oumuamua, it produces hydrogen, which becomes trapped under or inside the object's surface. When the sun's energy strikes Oumuamua, it triggers the release of this hydrogen gas, pushing the object at an incredible speed. While this speculation appears to be one of the most plausible explanations, it is by no means the most captivating. Are you ready to dive into the most unusual speculation about this flying object? Could Oumuamua be a piece of a destroyed planet? 2 astrophysicists at Arizona State University, Alan Jackson and Stephen Runn, put forth one of the most recognized theories concerning the origin of Oumuamua. Their speculation, considered one of the most solid explanations to date, suggests that this extraordinary object originated from a faraway planet in another nearby planetary system, potentially millions of miles from our own. They proposed that a space rock impact on that distant planet in the far past caused it to break free and embark on a monumental journey through space. Astronomers determined that this object didn't originate within our solar system by meticulously researching its trajectory when it was detected in our neighborhood on October 19, 2017. It was well on its way out of our solar system, wandering into the vast realms of deep space. As part of its legendary journey through the universe, Oumuamua made a brief refueling stop on our planet, serving as a messenger indicating the presence of other worlds beyond our own. The genuine intrigue lies in the fact that Jackson and Runn have not only pinpointed a potential source for this odd object but have also proposed theories about the planet from which it came. In their assessment, they posited that Oumuamua most likely originated from an exopluto. Now, what exactly is an exopluto? In simple terms, an exopluto is an exoplanet that bears a striking similarity to Pluto, the dwarf planet in our solar system. By analyzing the chemical composition and physical characteristics of Oumuamua, experts established that the parent body from which this object broke free, following a space rock impact, must have closely resembled Pluto. An intriguing connection arises when we dive into NASA's New Horizons spacecraft flyby of Pluto and its moons on July 14, 2015. During its mission to study the dwarf planet up close, this endeavor revealed features such as the Sputnik planum on Pluto's surface. What distinguishes these regions is that they primarily contain frozen nitrogen lakes. Nitrogen is difficult to come by on Earth, apart from the traces found on Pluto. Given this revelation, specialists speculated that Oumuamua could be a fragment of nitrogen ice expelled from a nitrogen-rich twin of Pluto in a distant neighboring planetary system. This discovery is profoundly exciting, as it suggests the existence of another planet similar to Pluto elsewhere in the universe. It also raises the possibility that there could be other planets like our own, potentially harboring intelligent life or even more advanced organisms than us. These hypothetical civilizations might be just as eager to explore a corner of the universe as we are to investigate theirs. Could Oumuamua be a spaceship from an alternate universe? The scientific community tends to lean toward natural explanations for Oumuamua, but there are reasons why some still entertain the possibility of this object having an extraterrestrial origin. What are the chances that, within the vast expanse of the universe, we are the only civilization? It seems highly unlikely, doesn't it? Yet, since there hasn't been any significant scientific evidence confirming the existence of these extraterrestrial beings or their advanced civilizations, most researchers dismiss the accounts and claims as mere manifestations of human imagination.